Edgeworks Nebula.
Hey folks, this is Lacey Hannan. On June 4th, privatized aerospace manufacturer and suborbital space flight company Blue Origin successfully completed its 5th human spaceflight. So, in celebration of the success of another commercialized trip aboard the New Shepard, we will be re-releasing an episode from our first season hosted by Alexander Winn. So join us on our own trip to Mars, where we will be face-to-face with some of the most massive geological features and mysterious eccentricities that exist in our solar system. And we'll learn about what they are still teaching us about Mars, Earth, and the rest of the solar system. In the meantime, happy terraforming.
Hello, and welcome to Settle the Stars. Mars, our future home. Hey folks, this is Alexander Winn. Today, we're visiting one of the most popular destinations in our solar system, Mars. The Red Planet has been the subject of countless sci-fi adventures from the time that mankind realized it was a place we could visit. From the 1800s, when observers first believed they saw artificially created canals on the surface, right up through today, we have hoped to find life on another planet, and Mars has taken the center stage in that search. Our trip to Mars will take us face-to-face with some of the most massive geological features and most mysterious eccentricities that exist in our solar system, and we'll learn what they're still teaching us about Mars, Earth, and the rest of the universe. Interspersed throughout the journey, we'll see examples of past observations and scientific theories that have been challenged and shaped by continuous study, and reflect on some of the cultural and historical impacts of the planet that we carry even today. Today's visit will be imaginary, but it might not be long before you can book your own ticket to Mars. There are several space agencies and private corporations currently racing to be the first to offer passage to the planet. The current frontrunner is SpaceX, the venture headed by Elon Musk. So far, several successful tests have been conducted with unmanned visits to Mars slated for around 2025. SpaceX hopes to begin large-scale commercial trips in the 2030s, so intrepid explorers should begin saving now, as a ticket could cost you $500,000 or more. Fortunately for us, today's visit is cheaper, safer, and blessedly, shorter. The real deal will be a grueling 7-month swing through space in what's known as a transfer orbit. Instead of making a direct line from point A to point B, space travel always requires a little more finesse. Planets are always moving, and at different rates to boot, so scientists have to launch at specific times and aim not for where their destination is, but where it will be months in the future. Specific dates and times are important here, and if you miss your launch window, you could find yourself stranded on Earth or on Mars until the next favorable alignment. 7 months is no time at all to an astronomer, but to a traveler, it can seem like an eternity once the novelty of life in zero-G wears off. For most of the journey, there won't be much to see out the window aside from the endless stars, but some exercise to prevent atrophy and a couple of hundred in-flight movies should help to pass the time. As you approach Mars, you'll have a rare view at the inspiration for uncountable millions of humans who have gazed up at the planet from Earth. The deep orange-red color of abundant iron oxide represented blood and fire to many ancient stargazers. Small wonder that the planet became associated with war, violence, and destruction to so many. Most people today know Mars to be the Roman god of war, carried over from the Greek god Ares. In fact, in modern Greek, the planet is still referred to as Ares. But such a prominent and unique object in the sky was the focus of interest for many other cultures, including the Chinese, who named the planet the Fire Star, and treated it as an omen which can foretell the coming of war, bloodshed, and destruction. In Sanskrit, the planet is called Angaraka, another deity of war. But not all cultures attributed the red color to calamity. The ancient Egyptians named the planet for the red god Horus, in charge of kingship and the sky, and ancient Hebrews called it Ma'adim, or the one who blushes. The symbol of the circle and projecting arrow that many recognize as the symbol of the male sex was first seen in manuscripts from the Middle Ages to represent the planet Mars, as well as the element iron. This symbol is actually a pictograph depicting an ancient spear and shield, holdovers from the cultural association with war. From the window of our ship, it's clear no wars are currently raging on Mars. In fact, from here it appears still and quiet. Even though we're close, the smaller size creates an illusion of distance, as the curvature of the planet is much more pronounced than Earth would be at this altitude. Mars is only about half the diameter of Earth. Depending on the timing, you may be able to see the two moons of Mars, Phobos and Deimos, named after the Greek god Ares' children. Evidence suggests that the moons are composed of materials normally found in asteroids, to say nothing of their irregular, potato-like shapes, leading to one theory that they are actually foreign objects captured by the planet's gravity. But there are also clues that support another theory, that Phobos could have originated from materials ejected from Mars itself as the result of a massive impact event. Invisible at this distance are our predecessors from Earth, still circling in orbit around the planet. There are about a dozen man-made satellites currently orbiting Mars, some long dormant, some still busy collecting data. Beginning with the first successful flyby in 1965 by NASA's Mariner 4 probe, and first ever successful orbit achieved by Mariner 9, the constellation of spacecraft has only grown. Most of the satellites still in orbit today are too small to be viewed at this distance. If you can see them, you're getting way too close. Evidence of past calamities on the surface is clearly visible, though, from massive scars at various locations around the planet. The southern half of Mars is pockmarked by craters from ancient collisions. Large meteors rarely burn up in the thin atmosphere, visible from here as a thin band on the horizon. By contrast, the northern part of the planet is relatively smooth and significantly lower in elevation. There are vast plains flattened out by lava flows millions of years ago. One theory is that billions of years ago, Mars was impacted by a massive object hundreds of miles across, which literally knocked the top off the planet. That would make the northern hemisphere of Mars the site of the largest known impact crater in the solar system, as large as Europe, Asia, and Australia combined. Shining bright white against the reddish-brown soil, we can clearly see the polar ice caps, one of the most promising early discoveries about the planet. Finding frozen water on one area of the planet while being absent from other areas could suggest an intermediate zone where liquid water can exist. Such a zone would bode very well for the hope that Mars could be capable of supporting life, either Martian life in the past or visitors from Earth in the future. As we descend for landing, some of the major geological features of the planet become more pronounced. Great mountains begin to rise up, with valleys, plains, and even canyons carved throughout the landscape. One mountain in particular is unmistakable: Olympus Mons. The gargantuan shield volcano of Olympus Mons, also known as Mount Olympus, is easily visible from space and one of the largest volcanoes in the solar system. Towering 2.5 times as high as Mount Everest, the shield volcano sprawls over an area roughly the size of France. That's roughly the size of Texas for you Americans out there. We could visit it up close, but ironically it wouldn't be all that impressive. The volcano is so large that the curvature of the planet would prevent us from seeing the profile of the mountain. It's a mountain so huge, you have to be in orbit to see it at all. Another unmistakable feature we can spot on our way down is the massive system of canyons known as the Valles Marineris, or Mariner Valley. This sprawling network of valleys and crevices stretches over 2,500 miles across the face of the planet and gouges nearly 23,000 feet deep. If you were perched on the edge, the opposite canyon would be up to 120 miles away, way too far to even see across. Basically, imagine the Grand Canyon, but 5 times deeper and stretching from New York City to Los Angeles. The Valles Marineris and Olympus Mons appear to have formed around the same time as each other, along with a huge number of other massive volcanoes and lava plains on the planet during the violent Hipparian period of Mars's geological history, which ended about 3 billion years ago. During this cataclysmic transformation, Mars experienced planet-wide volcanic activity and catastrophic flooding, which carved massive canyons across the planet's surface. Now safely aground at our landing site, it would be hard to believe that such a period of upheaval happened here. The ground is rocky and flat, and the sparse atmosphere barely whips up the dust to welcome us after our long journey. One of the first stops as tourists has to be to visit an old friend. Not far from where we landed, a small metal rover waits for our welcome. This particular rover is called Sojourner, and it's been waiting for us here since 1997. NASA lost contact 85 days into what was supposed to be a 7-day mission, and it's been here ever since. About the size of a dog, with 6 wheels and a little solar panel, this experimental rover allowed NASA scientists to develop new methods for movement and control that would improve later designs. Slowly and carefully, Sojourner's top speed was about 1 centimeter per second. It managed to journey 330 feet from its home base, and now with us here, Sojourner can retire to a pampered life in Mars's first museum. Since the first successful rover, Mars 3, achieved by the Soviets in 1971, there have been 7 sent to the planet over the years, with 2 NASA rovers currently active on Mars right now, Curiosity and Perseverance. And the Chinese Tianwen 1 is en route to join them shortly. The 7 rovers are spread out across the planet, so we can't visit them all on our trip today, but they have collected invaluable information about the atmosphere and geology of the planet that helped to make our human mission to Mars a reality.
I co-own a mobile gaming company, and the success of our business hinged on growing and engaging our audience. With Squarespace, you can do just that and way more. From websites and online stores to marketing tools and analytics, Squarespace is the all-in-one platform to build a beautiful online presence and run your business. They've got easy ways to create email campaigns to entice people to engage and check out all your hard work. Squarespace also gives you the opportunity to collect donations. When it comes to selling merch, Squarespace can streamline that too with inventory management, a simple checkout process, and secure payments. So go ahead and start up that new project. With Squarespace, the possibilities are totally endless. Head to squarespace.com for a free trial, and when you're ready to launch, go to squarespace.com/STS, and you will save 10% off your first purchase of a website or domain. That's squarespace.com/STS.
One of the most daunting challenges faced by engineers designing these manned and unmanned missions is dust. All this dust. It's incredibly fine, more like talcum powder than sand, and covers the planet so completely that no environment is spared. For mysterious reasons, it even kicks up into massive, planet-wide dust storms every few years. The dust can cover camera lenses and solar panels, clog mechanical components, and disrupt radio communications. It will be a major part of life for early Martian explorers, and has already been the bane of several rover missions so far. The dust is carried on the wind of Mars, which can blow quite strongly considering how thin the atmosphere is. The air pressure is exceptionally low compared to Earth, less than 1% of what we're used to. At that pressure, the air has to move very quickly to move dust at all, and wind speeds have been clocked at an average of 10 to 20 miles an hour, reaching as fast as 70 miles an hour in a dust storm. Compared with the nitrogen and oxygen-rich air we breathe on Earth, the atmosphere on Mars is almost entirely composed of carbon dioxide. It is a heavily oxidizing atmosphere, which explains the rich orange-red color of the planet, imparted by the iron oxide present in the dust and soil. Basically, Mars is red because the entire planet is rusting. As we look around, the sky is colored a similar reddish-orange, thanks to the dust particles in the air. But as the sun sets, we can look forward to a brilliant sunset of orange and gold that changes to a lavender and blue twilight against a curtain of wispy, high-altitude clouds. As night gradually falls, twilight lasts a bit longer with the light scattering through the dust in the air, we can see the stars shine. The dust dims them about a magnitude of brightness, but that's still better than you'll get in most suburbs on Earth due to light pollution. And here on Mars, they don't seem to shimmer or twinkle. The atmosphere is too dim for that, so their light is steady and unchanging. Nighttime also gives us a better sense of the movement of the planet we're standing on. A day on Mars is remarkably close to a day on Earth, only about 39 minutes longer than we're used to. And if you're curious how tough it is adjusting to the new sleep schedule, just ask the NASA engineers responsible for keeping Curiosity and Perseverance busy all day. They keep a Martian schedule for their work, shifting both their work hours and sleep schedules backward by 40 minutes every day, something that the payroll department probably finds less than entertaining. Not that we're bothered thinking about pay while looking at the Martian night sky. In the west, we can watch Phobos rise from the horizon and march across the sky quickly, setting again in the east after taking only 11 hours to cross the sky. It appears to us about only a third of the size of Earth's moon, but the pale color would make it stand out like a bright pebble in the sky. Deimos, on the other hand, rises from the east and sets in the west, not because it moves in the opposite direction, but because its orbit is so much slower than Mars rotates on its axis. Basically, we're moving faster than it is, so it appears to move backwards. It's larger than Phobos, but much farther away, so to us on the surface it would appear more like a very bright star. If we had visited in 2014, we would have had a seriously spectacular show. The comet Siding Spring had made a close pass near Mars, so close in fact that the entire planet may have been engulfed in the comet's tail for a brief time. As for other light shows we might enjoy, you might have heard of an aurora phenomenon detected on Mars back in 2016. Unfortunately, we won't be able to view the skylights ourselves, as the light show is only visible in the ultraviolet spectrum during the day, but our electronic sensors can sure enjoy the spectacle, and they've taught us a lot more about Mars. On Earth, an aurora is caused by the collision of charged particles from the Sun with molecules in our upper atmosphere. They only occur near the poles because these charged particles slide off the planet's magnetosphere like water across a giant balloon, circling back around to the poles where the magnetic field originates and sparking the light show. Mars has only vestiges of a magnetosphere left. The magnetic field collapsed about 4 billion years ago. Without the planetary shielding, the Martian atmosphere has gradually been stripped away by the solar wind over the course of billions of years. NASA's MAVEN orbiter studies the upper atmosphere of Mars, and according to the data collected, it appears the planet was once surrounded by a more robust, humid layer of air before it was lost to the sun's energy. After a night of stargazing, a new Martian day means more exploration for us here on the surface. One of the most important places for us to visit has been impenetrable for our orbiters and landers so far, and the most promising for well-preserved evidence of life: caves. A series of cave entrances has been spotted by one of NASA's satellites along the face of Arsia Mons, a large volcano in the Tharsis Basin southeast of Olympus Mons. Likely formed as part of the volcanic process, these caves are well protected from meteoroid impacts, erosion, and damaging radiation from the sun. Obviously, they're impossible for a wheeled, solar-powered rover to explore, but for humans, a bit of off-world spelunking is space exploration 101, so we can get a close first look for ourselves. Inside, we might find evidence of liquid water, either in molecular traces, water requiring mineral deposits, or flow erosion. All these clues have been spotted elsewhere on the planet, usually in the basins of craters or up against sheltering cliffs and mountains. In 2018 and 2020, large salty lakes of liquid water were detected by the European satellite Mars Express. These lakes only exist underground as far as we know, where the sun's radiation can't reach them. It's a testament to the power of the long-term forces of transformation at work on the planetary scale to find so much evidence of flowing rivers, torrential floods, and even oceans all around us, but not a drop to be found on the surface today. Even if hidden underground or locked in icy stasis at the poles, the presence of water bodes well for the ability of any planet to sustain life. On Earth, we have learned that life has a way of surviving in even the most unimaginable conditions, but one requirement is essential: water. Water dissolves life-giving substances and allows necessary chemical reactions to take place. It can also act as an insulator, stabilizing temperatures to make it easier for fledgling life to gain a foothold. Life, as we would recognize it, is simply impossible without water. Alongside H2O, there's one other chemical component generally understood as essential for life: carbon. The multi-tool of the periodic table, carbon's unique expertise as a molecular brick-and-mortar building block makes it the go-to backbone of essential molecules, from sugars to proteins and everything in between. Fortunately, with an atmosphere rich in carbon dioxide, Mars has carbon in spades. So, we've spent time searching for the requirements of life to survive, but what about the outputs it generates? Can we detect life by looking for the byproducts of living organisms? As it turns out, scientists have been looking there too. A common metabolic product of living organisms is a simple molecule called methane. Methane doesn't last long in the wild, breaking down naturally in just a few years, especially in the highly irradiated atmosphere of Mars, so its presence would mean an active source. As it turns out, satellites around Mars have detected large plumes of methane on the planet, which suggest localized sources somewhere underground. Scientists and ET enthusiasts should keep their excitement in check, however, as there are several geological processes that could produce plumes of methane. But it is a very promising sign. So now, with our sightseeing complete, the hard work begins. The exploration of Mars means more to humankind than just the opportunity to learn more about planetary formation and evolution. It provides a space and a safe, relatively speaking, environment for building our first habitats away from Earth. Mars sits on the edge of the massive and dangerous asteroid belt. Assuming humankind's exploration of the solar system is only beginning, Mars could provide an important space for repair and refuel for spacecraft heading further out into the unknown. Cities could be supported by local economies based on the mining, low-gravity manufacturing, and even tourism industries, as the foundations we lay now continue to grow. Just imagine the competitive sports scene on a world with 39% the gravity of Earth. Of course, I could go on about Mars for hours and hours, but we'll leave it there for now. As the single best candidate for human exploration in the solar system, we'll be returning to Mars again soon. But in the meantime, we'll continue our exploration of the solar system by venturing further out away from the sun to visit the stately gods of the outer solar system, the gas giants. In the meantime, be sure to subscribe if you haven't already. Settle the Stars is available on pretty much every podcasting platform, and we're also mirroring our episodes on YouTube at youtube.com/edgeworksentertainment. And be sure to ring that bell so you know when there's a new episode. And don't miss the other awesome shows that are a part of the Edgeworks Nebula: Slice of Science, The Synthesis, and our upcoming show You Have My Sword, where Christy Pride will be analyzing and deep diving into the world of Lord of the Rings and J.R.R. Tolkien's Middle-earth. Thank you all for listening, and as always, happy terraforming. Settle the Stars is a proud member of the Edgeworks Nebula, a collection of intriguing and informative podcasts from Edgeworks Entertainment.
Edgeworks Nebula.